The alkali metals. So, interesting. You can list their symbols, obviously starting with lithium, going down the group. And while you're doing that, have a look at your periodic table. It's worth Googling the origins of the word alkali, because it goes back to the ancient Arab cultures, and it's an Arab word, as often words that start with al are, and it's to do with burnt ashes. It's the remnants when things were burnt, wood was burnt. You get the alkali metals and salts of the alkali metals in the residue of a fire, which is obviously something they were aware of, and the properties of some of these compounds. So, you've listed their symbols, and we'll talk about their properties. They are quite special. They're very soft. I say very soft, they're not as soft as jelly, but they're definitely a lot softer than your typical metal, like iron. So you can cut them with a knife. As you go down the group, they become softer. Okay, you'll see that in some of the videos online, and there's a little video of sodium on the next page. So they're soft metals. They generally have a low density, and their density generally increases down the group. What evidence do we have that they have a low density? Well, again, you'll see in some videos, but they actually float on water. When they start to react with water, they float on the surface. Okay, so you can fill in this gap. When they react with water, they float on the surface, so they must be less dense than water. If you think the water's got a density of 1 gram per centimeter cubed, and something like tungsten's got a density of 20 grams per centimeter cubed, more than lead. Tungsten's one of your transition elements, and these elements have a density less than 1 gram per centimeter cubed. They float. They're silvery and shiny when you cut them, but they quickly tarnish. They quickly go dull. Why? Well, the surface obviously is exposed to the atmosphere, so they'll start to react with oxygen and perhaps some nitrogen, but oxygen's the classic thing for them to react with. So their surface will tarnish quickly. It will go dull. And they have low melting and boiling point, and the melting point decreases down the group. If you look at the periodic table, at the bottom of group 1, obviously you've got some metals there that are actually liquid at room temperature. Okay? You'll see this as well with the reactions we'll talk about in a second. The reactions with water, the metals actually melt. Why does the melting point decrease down the group? Well, essentially, the metallic bonding is not as strong because the atoms are bigger. So there's a bigger distance between the ions in the lattice of the metal structure and the delocalized sea of electrons. So there's a weaker force between them, and obviously it's easier to overcome. So the melting points and boiling points are less as you go down the group, as the atoms get bigger. They're exceedingly reactive, very reactive. The reactivity increases down the group. So the 3 that we'll see, potassium's greater in reactivity than sodium, is greater than lithium. Okay, now why? Well, let's have a look at the atoms. You can see that the atoms, the electron in the outer shell, is further from the nucleus. So, because it's further from the nucleus, it's actually easier to lose as you go down the group. So lithium has quite a tight hold on its electron, whereas potassium, well, especially with all of these electrons here, this electron out on a limb is very easy to lose. So it's very reactive. Okay, so let's have a look at how group 1 metals react with water. We can use this to compare the reactivity of the three metals that we've got some use of in school. So they all react vigorously when placed in water. But as they go down the group, the reactions become more and more vigorous. You could even describe the potassium reaction as explosive or bordering on explosive. So lithium, when it reacts with water, it forms lithium hydroxide and hydrogen gas. The astute amongst you will realize that this needs to be balanced. Have a little go. There you go. Because you want one hydrogen molecule, then obviously you need to multiply everything else by 2. Just double check to make sure you've got everything you need there. Observations, you have to write them down for yourself. The lithium floats on the surface, effervesces, it skims around on the surface, and it slowly dissolves into the water. You can find videos on YouTube. Sodium, exactly the same reaction because it's got the same valency, so it'll be the same balancing as well. The observations here, well, the sodium floats on the surface and effervesces, but because these reactions are exothermic, the sodium actually melts and then skims around as a little molten ball of silvery metal, skims around on the surface and slowly dissolves. You can see this reaction. I've videoed this. You can see this by clicking on this link. And potassium reacts in the same way, same balancing, clearly. This is a bit more spectacular. The potassium melts, it effervesces, it skims around on the surface, great, but it also catches fire. And potassium, when it burns with a lilac flame, so it catches fire, burning with a lilac flame. It slowly dissolves, and then at the end, because of the temperature, it often spits and explodes, and you get little bits of potassium flying everywhere. If you do it on a large scale, it's quite dangerous. You need to fill in those observations. Okay, some notes about the group 1 metals. In all cases, the resultant solution is alkaline. Why? What makes a solution alkaline? It's the OH minus ions, isn't it? It's the lithium, sodium and potassium hydroxide that's formed, OH minus. And you could show that by adding an indicator, like universal indicator would turn blue, purple, litmus would turn blue, to show that this was an alkaline solution. All of the reactions are exothermic. How can you tell? Well, because the metals, in the case of sodium and potassium, the metals actually melt due to the heat of the reaction. And group 1 metals are excellent reducing agents. Why? Well, reduction is a gain of electrons. So group 1 metals are very good at forcing electrons on other things. And if they force an electron on something, then that thing is reduced. Okay, but any reactive metal is a good reducing agent. Okay, essential chemistry, pages 154, 155, and answer the questions.